Today, Egypt is building. Factories, power grids, and critical infrastructure are expanding rapidly to drive modern economic growth. Supplying the energy for this expansion requires massive petroleum operations. Offshore drilling rigs and vast pipeline networks run constantly to keep the country moving. But these heavy industrial sites sit inside highly sensitive, biologically rich marine ecosystems, like the delicate coral reefs of the Red Sea. A single structural failure or a ruptured pipe leading to an oil spill can wipe out decades of coral growth, paralyzing the local tourism economy. Historically, managing these threats meant relying on a reactive approach. You wait for a pipe to burst, sound the alarm, and scramble to clean up the mess after the damage is already done. In highly sensitive ecological zones, waiting for the disaster to start guarantees destruction. The fragility of these waters demands an integrative model, a proactive system designed to stop the failure before a single drop of oil hits the water. The first line of defense in this model is total quality management, or TQM. By enforcing strict daily operational discipline, mandating routine checks, following standardized procedures, and constant equipment audits, companies catch human errors and minor mechanical faults well before they compound into systemic failures. To scale this discipline across hundreds of miles of pipeline, the system uses orbital surveillance. Sentinel-1 satellites continuously bounce radar waves off coastal infrastructure to monitor operations from space. Artificial intelligence algorithms digest this continuous stream of radar and internal pipeline flow data. If the AI detects a microscopic pressure drop, it flags the exact node hours before a physical rupture can occur. This map outlines Egypt's natural protectorates, illustrating the sheer geographic scale of the zones requiring this surveillance. With sensitive sites scattered from the Mediterranean coast down through the Red Sea, physical monitoring alone is impossible. By combining strict operational discipline with predictive AI, the standard of success shifts. The goal is no longer a fast cleanup. The goal is the disaster that never actually happens. Predictions are rarely perfect. When an incident does occur, the response moves instantly from the before phase to the during phase. Mandated by Law 4 of 1994, a confirmed environmental threat immediately triggers the activation of a centralized emergency operations room. Individual, competing petroleum companies connect instantly to government responders through a unified crisis network. Isolated data streams merge into a single, real-time situational map. This shared map is crucial because disaster response requires ruthless triage. With finite resources, containment efforts must be deployed sequentially to protect the most vital assets first. Strategic and economic lifelines, like the Suez Canal and major coastal ports, take absolute priority. Securing these zones prevents the physical spill from triggering a secondary logistical collapse. Coordinating this data-driven triage is the only reliable way to minimize widespread economic devastation during the chaotic first hour of a crisis. Once the immediate threat is contained, the protocol enters the after phase. This period dictates how the environment is rehabilitated and how the event is used to tighten the system's safety rules. Every action taken, delay encountered, and resource deployed is logged into a national incident database, transforming a temporary emergency into permanent institutional memory. Investigators determine the exact root causes of the failure. Those findings are then distributed across the entire petroleum sector to update the daily TQM procedures of every company. A disaster only becomes a total failure if the system refuses to analyze the data and adapt its predictive models to prevent the same mistake twice. The profile of an environmental responder has changed. They are now tasked with engineering prevention through predictive analysis. This approach aligns directly with Egypt's Vision 2030, which explicitly ties continued economic expansion to stringent environmental sustainability. Protecting these ecosystems depends on the seamless integration of satellite telemetry, AI forecasting, and strict legal accountability. Egypt's natural environment is its most irreplaceable capital. Proactively defending it is the absolute prerequisite for the country's long-term prosperity.